got this one set up. Okay, so if we jump back over to the code section, let's look at just a few more things. Um, this page has kind of the remaining things that we got to cover. It has the electric range information. It has the non-coincidental loads, and it also has the EV cars as well. So bottom left of this page 96, we have the electric cooking appliances in dwelling units and household cooking appliances used in instructional programs. So again, this is a law book, so they even cover if you have some kind of cooking course that you're teaching somewhere, that applies to these too, right? Because where else could we have, other than a restaurant, right? Other than a restaurant, we got houses can have ovens and cooking appliances, and also if it's not a restaurant, then like a school, instructional programs that teach cooking. So let's make sure we understand, because cooking appliances could be a little bit confusing as to what is specific. Is my air fryer a cooking appliance? I mean, technically yes, but so what they're talking about here is the load for household electric ranges. Remember what I mentioned, and I'll just kind of draw it a little bit. The range is the stovetop, right? Whatever it looks like for yours. And then in combination with the oven inside as well. Okay, this is what they call a range. It is a bigger appliance, one of the biggest appliances, if not the biggest appliance that goes in the house. A few things about the oven or range. I like to just call them ranges when we're in class. But if I'm home, I just say, put that in the oven, and I might just turn on the stovetop or something, right? I don't really say, go to the range and. It has the largest outlet, which is a 50 amp outlet. All right, these days, these are 4-wire setups, so it looks something like that, which you guys will, what do we call B? So next module, you actually wire up one of these larger outlets. There's two types that float around our lab for Code C. There's the smaller one, which is 30 amp, smaller in amperage, not in size. They're actually both the same size. The oven one is the 50 amp one. So I think both of them float around the lab. It's just to teach you guys how to wire up a 4-wire 240 volt outlet. So this is what the oven is, or rather I should say the range. Now we can also have a wall mounted oven. No stovetop, just in a wall section, just an oven, just that's all it does. You open it up, put it as use it as an oven, close it up. All right, I've seen these. I've never owned a house that had one, but I have seen those. And then countertop cooking units. So that means get rid of the oven now, and you just have the stovetop. And so if a house, for example, has an oven that's in a wall-mounted system, then probably on the kitchen counter, they just have the stovetop. So all of these are bunched up together, whether it's the combo or whether it's singles, oven, and cooktops. And other household cooking appliances individually rated in excess of, and there is where it starts to separate our air fryer. That is 1,750 watts. Okay, so it is very unlikely that anyone even has a microwave that is 750 watt. 1,750 watts. Even a big microwave that somebody gets for their house is going to sit somewhere around 800 watt. This is one of those bigger giant microwaves. A convection oven, right? The little ovens that you can put on the countertop, and literally it can cook a whole chicken, but it's still not going to reach that level of wattage. So there's the cutoff point for the wattage. You don't have to, if you wanted to underline it, it's fine. I don't think it comes up as a question at all. All right, as to which, or at what point we consider it not a household cooking appliances versus, I'm not going to ask something like that. All right, so we have the table. So let's jump over to the table. Make sure we wrapped up class yesterday with this, but one, I want to get it on video. Two, I just want to go over it again a little bit slower because a lot of you were packing up at the end. So this is a demand factor. Just to remind you what a demand factor is. It is a factor based off of how, or what I should say, is the odds are, or odds on this particular unit turning on all of them at the same time. So, when we were doing the general lighting load, we took away 3,000 watts and said, hold on to those, we're going to value those at 100%, but that remaining wattage, we're going to use a demand factor of 35%. All right, another way that we say that is to derate it. All right, this is actually pulling a word that is more used for conductors when we go through that temperature correction factor and we say, okay, the conductor's sitting at 175 degree Fahrenheit and the percentage that we're going to take, that is actually more derating. All right, it's removing amperage from something, not factoring in any kind of time frame that. But you will hear electricians mix it up and use that word a lot for demand factors. Derate, all right? Take away something from that. So it already starts off that if you have one of those cooking appliances, let's just say a range, because this is likely what most people have is the combination. Although, again, plenty of wall-mounted ovens and single burner cooktops and all that stuff. But on average, most people have a range. So already, they're not calculating the range at 100% value. Even if you had only a stovetop setup, right? A countertop mounted unit. Are you using all 4 of the burners? Always? No. Sometimes, maybe. So because of that percentage already off the bat, if we have one oven, then we're going to factor in the VA at 80% of whatever it is, even just for one oven. Now, there's 2 columns. We're going to ignore column C. Column C gets into very large size units, and we don't have to worry about that. And it gets a little bit complicated. Just want you to understand the principles of everything, all of this. So we have 2 columns, and they're based off of the size of range that you're going to use. All right, and this is given. All right, this is a given that has to be calculated in for the panel that we're setting up. So this is usually given by the blueprints as to what size the oven's going to be. So 3.5, so 3,500 watt. This is the column that we go into. And if it's 3,500 to 8,000, well, I can barely see that, 750 watts, then we're into this column. Now, once it starts to get large, right, once this thing goes into a bigger than 8,750, but not larger than that, it starts to get into a way more complex calculation. All right, this now then becomes about the wattage, and starts to get a little too complicated to have to deal with right now. So for now, we're just gonna, like I said, we're gonna ignore column C. We're gonna use column A and column B. Nothing fancy about them. Just if the problem that we're working out says 2,500 kW or 2,500 watt range, then we're using column A. If it says we're in a 5,500 watt range, then we're in column B. All right, I'm going to erase that to not, but I am going to leave the X on C. All right, now we can look at the article just to keep reading it. Let's head back up here. Use the table 2255 shall be considered equivalent to the kW for loads calculated under this section. There's a couple of informational notes, but nothing else to worry about there. All right, now we're going to get back to all of this. I just want to wrap a few things up while we're on this page, and then we'll jump back over to where we're at. Now, it's an other than dwelling unit 22056. So for now, let's just ignore that. All right, we're not going to worry about other than dwelling units for right now. We will just pepper in a few questions about specifics like sign outlets and things like that, but we're not going to do a full load calculation here, so we don't really have to get into this kitchen equipment setup. Let's jump over to the last two that I want to cover, which are the EV 22057. All right, in 22057, this one is like the dryer, where we have a minimum versus. All right, I covered this one yesterday, but just to go back over to it, I have the dryer and this one in the same page, only because they're the same. So I just wanted to point that out. There is a minimum versus nameplate. And then we're going to pick larger of the two. All right, this is both for dryers and for EVs. For dryers, 5,000. For EVs, a little bit bigger, 7,200 watts. All right, and these are usually 240 volt loads. They don't have to be 240 volt loads. They just become a little bit more complicated to wire up if you were gonna make this 120, right? Because you're looking at 60 amps if you make this 120. Right, starts to get very large at that point. So if you take 7,200 and divide it by 240, then the amperage drops down to 30 amps. So this would be the breaker size, this would be the outlet size, and you will have calculated 7,200 watts for the panel to deal with. All right, so nothing complicated here. Again, we're going to get to a whole question, so we'll approach these as needed. Again, just keep in mind.
Because that's what the service load is?
Say that one more time.
Did you divide it by 240 because that's what the service load is? Because typically 120, 240, right?
Yes, for depending on the unit, but for the dryer, the oven, and the EV system, air conditioner as well, and water heater, it's divided by 240 because these are 240 volt loads.
And when do you divide by 120?
When you have 120 volt loads, that's a good question, because when it comes to the EV, you could actually use either or. You can use single phase 120 volt outlets. They charge 20. It takes forever to charge, so people don't usually opt for that. I have seen people try to go cheaper and get a cheaper outlet, but it ends up being more cost because the wires become larger and all that. So you only divide by 120 when the piece of equipment that you're using is 120 volts. A garage motor is one of those, would be 120. Like an outside pump, that would be optional, 120 or 240. They come with either or. But for the calculations that we're going to be doing today, we're only going to be using 240 because we're going to be calculating the entire house load. And so for the entire house load, we're now going with the entire house voltage of 240. If we were, for example, let's just do a quick side here. If we came up with a general lighting load, right, after we did the 35% and calculated, and we came up with a number that we had yesterday, that's why it's in my brain right now, 4,050 VA, then I would divide that, if I'm trying to find breakers, by 120. Believe this is what we did in week 1 or 2 with that 210 article. All right, we divide now 4,050 by 120. It gives us 33.75 amps. And now are we using 20 amp breakers or are we using 15 amp breakers? You can still use 15, so you can divide that by 15. And then remember, all outcomes here become 1 up. So this would be 3 breakers that we would have to get for. So that's a little bit different, but because we're doing general lighting loads, we calculate. But now we're doing branch circuit stuff. We're doing branch circuit overcurrent protection device selection, which is a little bit different than what we're doing today. Today we're coming up with the main panel size, obviously overcurrent protection device size, and we're going to even do wires as well. All right, we'll get into wires also Yeah, do I have anything to add there? No, I think we're good. All right, so the EV is a mandatory in homes that are new now, uh, and and they're adding them all over the place. So you can also always do an individual load calculation. So for example, let me just, when can we use what you were asking there? Well, let's say let's say a house doesn't have an EV charger and they're buying an EV charger. And they tell me, oh, this EV charger says 6,000 watts and we're going to be connecting it to 240 volts. So if I want to find an overcurrent protection device, this is my approach. Right, and I have what, 25 amps there. I believe the code, don't quote me on this, believe the code says we have to have a minimum of 30 amps for this one. So that would work, 30 amps, run number 10 wires. And so when you're doing individual loads for, add-ons, this is where, again, Ohm's law, P over E equals I is one of the most used. E times I equals P wattage sometimes, but most of the time, not really. There is going to be an application for that, and it's when you're trying to size transformers. All right, let's look at the last note. As I said, this is air conditioning loads, as you can see down here. Non-coincident. Now, I'm going to read this. It's a little bit confusing, but I'll boil it down to what it's saying. If it is unlikely that two or more non-coincidental loads would be in use simultaneously. So, what are two non-coincidental loads that are unlikely to be on simultaneously would be, for example, a heating and cooling system in the house, right? Either I have the heater on in the house or I have the air conditioner on in the house. I cannot have both. The units will not do that. You will use only the largest loads that will be used at one time for calculating the total load of the feeder or service. If a motor or air conditioning load is part of the non-coincidental load, if like there's a motor in the air conditioning system and is not the largest of the that gets a little bit too complicated, 125%, so let's not go that far. So here is as far as we go. All right, make sure you have that highlighted. All this is saying is, if you have a heating and cooling system, you are going to take the larger value of those two. Now, this is going to be on the nameplate of the air conditioning system. All right, so this is one of those that is given to us. All right, there's no house that gets built without the air conditioning system. Unless the house is not going to have an air conditioning system, then we don't have to account for it. If it's in a cold climate and the only thing they're worried about is heating the house, then fine. We don't put an air conditioning system and we don't calculate it for our panel. Not mandatory like the other ones that were mandatory. So if I have an air conditioning system, for example, and it says that the heating is whatever, let's just go with 3 kVA. Let's use some those terms. And I have the cooling system, and this one says it's 4 kVA. Then I'm going to take the larger of the two at 100% of the nameplate value. All right, there is no derating here. We're not lowering any of the percentages of the two. Because air conditioning and heating systems are probably on all day. So this is one of those that likely is on all day. So there's no derating for it. All right, so any follow-ups? All right. So let's do this. Give me 1 second here. Let's work out a problem. All right, let's work on a problem here. here we are. All right, so let's start here. Actually, I believe there's one that I skipped. Yes, sorry about that. There is one that I skipped. So let's go back for a second here. Sorry about that. 22053, I do have to mention this one. 22053. I believe it's this one, yeah. Okay. So 22053 is for appliance loads. Now, when it says appliance loads, they're meaning anything that's not a laundry, right? Anything that's not a dryer, the oven, or any of those components. So things like the dishwasher, right? That's an appliance, and it's large enough to consider. Garbage disposal, that would be another one. Water heaters can factor in as well. It's a little bit of a toss-up with some of these. It can fall under appliance. And like, for example, this question has the range hood. All right, that is the little thing that you turn on that pulls all the smoke from over the oven as you're cooking, or over the range as you're cooking. So we can have other things, all right? We can have other appliances that we'll have to deal with. But these are in general the only extra ones. I'm trying to think of other things that could possibly be in a house. I mean, somebody can have freezers and stuff like that, and maybe you consider things like that. If the house is coming with a freezer system already, then anything else can start to be added into this. But as far as what is common for a house would be not a freezer, not a wine cooler or something like that. So those things are not factored in. So if we get givens like this that we are being told, then they fall under that 22053, where it says applying a demand factor of 75% to the nameplate rating of, here's the thing I want you to underline, 4 or more appliances that are, we're going to ignore this quarter horsepower, that are 500 watts or greater. All right, so there needs to be 4 of them. They need to be 500 watts or greater, that are fastened in place, and that are served by the same feeder service as, of course, the house. This demand factor will not apply to the range, the dryer, heating, and cooling systems, and it will not apply to the EV.
So what happens if you have 4 different appliances that are rated above 500, but they're at different wattages?
They're rated more than 500?
Yes, because it says greater or 500 watts, or it says 500 watts or greater. So let's just say hypothetically you have one that's 500, 550, 600, 650. Do you add all those together and then get 75%?
Yes. So you add these all up, 5, 12, 22, and then you multiply that by 0.75%.
Okay.
Now, let's follow your question with, what if there's less than? Because what we have here is one excluded, that 400. That 400 now makes it 3 of them that are over 500, yes, but this 4th one is not. So we do not apply to what we're looking at here in this question. We would not apply the 75%. But to the numbers that you gave me, 5, 5, 6, and 650, yes.
So do you not, so you said you don't include it, but since it's not over four, what do you do? Do you still have to factor the 75%?
So for this one here, no, we just add all these up. We would do 800, I'm not going to rewrite that, 800 plus 2800 plus 850 plus 400, and that's it, 100% of its value.
Okay, so it's only if it's four or more, then it's given the 75%.
Exactly, 4 or more at 500 watts or more. Or, now we can look at the motor for a second, once that's made sense. For quarter horsepower appliances or greater, and that's where the garbage disposal, because this is actually a little motor, so it's not 4 at 500 watts or more, it's 4 at 500 watts or 4 quarter horsepower or more, and any combination of those two. If I have, like, let's say I also have a pool pump, right? I have a pool pump and it's a quarter horsepower.
Wouldn't the range hood have a fan?
Yeah, range hood is also considered, but we're not, yeah, we're getting the VA on this one, just the same thing as we're getting the VA on the disposal.
So if we're not given a horsepower, then we just don't consider it?
No, well, you're gonna need some information from the hood.
Okay, all right.
Yeah, you'll either need the VAs from the hood or you'll need the horsepower from the hood.
Okay, sounds good.
Yeah, good questions there. And again, it can be a little bit pause, wait a second, what is this thing? How does it apply? And let me think through it. This is why in most cases when houses are being built, it's not that the homeowner or the person selling a house wants to give more thing. It's just that it's best for the electrical system to know everything that's going to be in the house versus having homeowners come in with appliances later. And if you're building one house and for a single client, then you can work with the client. But if you're building a development, you got 100 homes going in, everything should be accounted for so that there's no questions on the electrical systems, what's needed as far as panels go for the houses. So all of these things are all factored in. So for example, we could have gotten, instead of the VA for this hood and the waste disposal, because the waste disposal was 850, I'm just going to say this one was a quarter horsepower. But let's say for this one down here, I'm only getting a 16th of a horsepower motor. Okay, so that one's smaller, and so I don't apply the VAs to it. Now, the reason why we're giving you the VAs is because you haven't gotten to the class yet that helps you convert horsepower to VA. But it's a very simple calculation, and I can just show it here real quick. You're going to deal with it in motors. But all motors or horsepower is equal to 174 watts per 1 horsepower. So for a quarter of a horsepower, then I would just 746 divided by 0.25, and that'll, well, wrong way to go with that. For a quarter of a horsepower, divide by 746. Wait, what am I trying to do? So a quarter of 746. My math right now is escaping.
Are we gonna have any problems like that for the exam?
There we go. No, not to this complicated level. Sorry, for a quarter horsepower, it would be 186.25 watts in that case. So definitely at 850 VA, this was much bigger than a quarter of a horsepower. All right, so that is a big waste disposal, but so yeah, if you're looking at here, and I'm telling you, 746 watts or VA is equal to 1 horsepower, and they're telling us that this garbage disposal is 850 VA, so it's clearly slightly bigger than a quarter of a horsepower. Sorry, yeah, I mean, it's slightly bigger than 1 horsepower, I meant to say. But no, we're not going to do any horsepower conversions here. That's why I basically said ignore horsepower. You're going to get VAs as the numbers that you're going to be working with. Let's see if there's anything here that I want to make sure that I All right, they got a little bit fun with the air conditioning system. They gave us a heat pump, which that's I don't know. I don't know a lot of homes that have that. This house does not have a cooling system, so if you have a heat pump system, you're have a cooling system as well. And I think what they're giving us here is that the heat pump system was the larger of the two. Just trying to see if I see anything else here that's. Oh, and last but not least, let's deal with these two. All right, these two here, which let me just go over to the guide here to point it out. And it comes out of Article 220.14a, which says anything else that doesn't fall under general lighting loads, doesn't fall under appliances, isn't a dryer, isn't an oven, isn't part of the air conditioning system, isn't an EV, everything else will be at the nameplate rating of the equipment. All right, it'll be at the nameplate rating of the equipment. We can drop back there for a second and pick that up. We did look at it, but this was when we did 214 other loads, all occupancy other loads. And then we got into just all these other little factors of other loads. All right, so we'd simply go with the nameplate rating on those and we'd make no changes to them. All right, specific appliances or load, an outlet for a specific appliance or other loads not covered in B through K shall be calculated based on the amp rating of the appliance or load served. All right, this is the section that we're looking at here. Now, it does say the amp rating of the appliance or load served. However, we're going to need to convert those appliances, and here's where E times I comes into play. Where I'm looking for P, I'm looking for that VA. I got to get to the VA of the unit. So if I know the voltage of the system, now here they're just giving us the VA. Which I'm just going to give you the VA. But for example, if the piece of equipment did not have the VA, and which happens a lot with a couple of these things, is that we don't get the wattage, we get the amperage that this thing operates at. So let's say, for example, this thing operates at 15 amps. Then if I know what voltage I'm connecting one of these to, garage door, for example, would be multiplied by 120. Spa, this can either or most of these, if they mean jacuzzi, usually get connected to 240. So because it can get complicated into that area of what am I connecting this to versus, we're simply just gonna get the wattage of it. All right, the VAs. All right, and that's it. That's all it says. Shall be calculated based on the amp rating or VA of the appliance. No changes, no anything to it. Just get calculated at 100% value. I think that's everything that's here because I want to go ahead and get started. Go ahead if we had another one. Now, I'm going to change this oven here. I don't like this range at that big. Does not, honestly, ovens don't get that big for houses. So we're going to change that to 7.5 kVA. That's the only change I'm going to make to this. All right, so with that being said, let's jump into this assignment and let's do it together. This is not the assignment that we're going to turn in. We'll also do that one as well. We'll do both, but because two things. One, let's go through the whole thing and apply everything. Might even do 2 of these examples, but this is not what's going to be on the exam 1 or the final exam or on your journeyman exam. They're not going to give you a whole house to calculate. They don't do that anymore. I think they used to, but not anymore. Instead, you're going to get pieces of this. You're going to get bits of this. You're going to get asked, what's the general lighting load, VA? What's the this? What's the demand factor? You're going to get pieces of it all. think. Maybe they do. Maybe they still do the entire house. Yeah. But I remember when I did my journeyman exam, not only did they ask you for the entire house, they would just give you all of this and go, what's the size of the neutral? It's like, okay, here we go. That is a long way to go before I get to what size the neutral is. All right, so let's do this one together. All right, let's start with our square footage. We're gonna, and we'll do all the math together. We're gonna start with the square footage of 1,800 times 3 VA per square foot. All right, I'm gonna move that over a little bit just to have space. Let me move everybody just slightly over. Should have done that the other way. There we go. Now everybody goes together. So let's drop back. I'll put it over here. 1,800 times 3, if anybody has that answer.
64,000.
60. Say that one more time.
6,400.
6,400 VA. All right.
It's 54.
Yeah, I think it's 54.
Oh, 54? 54. All right, now, first thing we do before we get to these two, all right, is we're going to now separate that to apply our first demand factor of the 35%. So we'll take this 3,000, separate it over here, take the remaining 2,400 and multiply it by 0.35. And then when we get that answer, we'll bring that answer back over to the 3,000 and continue down our route. So 2,400 times 0.35 should be
840.
840 VA. Very good. We'll bring it back over here. And now we have a total VA of 3,840 for our general lighting load. All right, that's for our general lighting load. Okay, now we're going to add to this our 3 small appliance loads, right? Now they're minimum we have to have 2. But here we're being told that there are 3 small appliances. By the way, if anything is too small, you can't see it, let me know. I'll maximize a little. But those are 3 small appliance loads, so they're going to get, now give me 1 second, I'm going to, this is all on video, so I'm going to erase if you need to see anything else. I'm just going to reposition at that number over here. All right, that's our general lighting. So we have 1,500 times 3, easy math to do in my brain, at least for me. 3,000 plus 1,500, 4,500 VA for small appliance. All right, so our small appliance load, 4,500 VA. And then our laundry circuit's only 1, so we
We have 3 small appliances and each of them 1,500. So you need some.
yeah, code says minimum VA for the small appliance loads is going to be 1,500. Now this is on, so what is, let me just also make sure, because again, this can be a little bit confusing because we get a lot of, for example, what's the difference between small appliance load and appliance load? Wait a minute, this is getting confusing. We have appliance load over here, small appliance load. So what are these things? Well, on the countertop of a kitchen, usually what you're gonna have is mandatory, remember our countertop spacing, right? We have to put outlets here. There's my symbol for an outlet. And then no within 2 feet, 2 feet, 2 feet, meaning, and by this is an exam 1 question, we'll review on Thursday, but it was 4 feet. 4 feet is the total distance that 2 receptacles can be from each other. Because no more than 2 feet, no more than 2 feet, total that up, receptacle to receptacle, 4 feet. Just to bring back that. So let's say I have a couple of countertop outlets here. These are not dishwasher. This is not disposal. This is not oven or range hood. This is blender. This is air fryer. This is coffee maker. This is those things. Providing outlets for likely small appliance, toaster, convectioner, things like that. So if you have a minimum of 2, which is required, then this means this. These 2 on one circuit, these 2 on one circuit. That would satisfy the code. Minimum 2 small appliance loads. And then we distribute the outlets. Right? This does get complicated. Then you distribute the outlets how you're supposed to over the countertop. If I got a tiny countertop, then I might even just have 1 appliance load from the panel. I might have just 1 20 amp breaker because I don't have a lot of space. Right? I don't have a lot of space. I only have this as far as countertop goes. Little apartment. So I might just have 1 20 amp breaker servicing 2 outlets. But when the size of the panel was calculated, minimum 2 small appliance load were calculated for that panel. I'm going to bring this back to where we were at. So when we're being told that there are 3 small appliance branch circuits in this kitchen, likely more counter space, more outlets. Those are those. That is what a small appliance load is. The outlets that sit on the countertop for small appliances. Like again, we don't know what maybe somebody doesn't have anything. No air fryer, no blender, no toaster, no anything. Fine. Coffee maker, unless you don't like coffee.
Mr. Perez?
Yes.
So even if you just had 1 small appliance branch circuit, you would count it as 3,000 VA
Yes, for the panel size.
for the panel size?
Yeah, for the panel size, it gets calculated at minimum 2. In case future expansion, future work, it gets updated from there. The code says minimum 2 for sizing your panel. You want to then have only 1 outlet and 1 breaker. That's a branch circuit setup.
Okay, thank you.
You're welcome. Now, if there's going to be more than 2, then we do have to reference that because my panel gets bigger. All right, so let's put this math together now that I covered what small appliance branch circuits are. That is carry the 1, 8, 9. Let me know if I've made any math errors there. So between general lighting loads, requirement 3 VA per square foot, requirement of our small appliance load, and the requirement of the laundry branch circuit, and I also like to mention this: people might not have a washing machine. All right, it might not have a washing machine, might not have a laundry room. But when they sized the panel, a laundry circuit was given a 1500 VA load calculation. Now, it's not likely that that's happening, so most places are going to have a laundry room. New construction, you got to think about that. But if there is none in it was still calculated for the panel. It's a single family home, apartment buildings take on a little bit of a different application. All right, so good so far. We have almost 10,000 watts that we are calculating in for our demands of general lighting, small appliance, and laundry circuit. So let's continue now, because here's what we're going to do. All right, everything else is 100% value, except for 2 things. No, except for 1 thing only. Not 2, sorry about that. So we're going to do these at 100% because of that 400 not putting us over the 4. I want to get that arrow off of there. Off of the 4 mark. So we add those up at 100%. These extra loads, full nameplate rating valued at 100%. Clothes dryer, we have 1 through 4 clothes dryers get 100%, just to go to that article. So we have no demand factor for the clothes dryers yet. We only have one of them, 100%. Heating and pump is going to be 100%. And then the only one that we're going to 80% is going to be the range. So we can add all this up now. It's not too complicated, except that once you do these a couple of times, then the practice comes in, and there's only so much that can be thrown at us. And then we just start to put the numbers together. So for example, if that 400 would have been 500, then we can add 75% demand factor to that. But since it's not, we're going to add all those up 100%. So 2,800 plus the 800 plus the 850 plus the 400. It's not a crazy. Go ahead.
So for appliances, they have to have, all 4 of them or more have to all be above the 500 mark?
Yes, all 4 of them have to be above the 500 mark. Versus horsepower, which we're not focusing on, but there could also be some horsepower here. But yes, all 4 of them would have to be over the 500 mark.
If there are only 3 appliances and they're all over 500, it wouldn't matter either?
No, it wouldn't matter either as well. Good question. There was 2 of them, and they were both 5,000. We ignore that. We just 100%.
Okay.
All right, we can add the garage and the spa as well. 750 plus the 6,500. Now we have a total. I'm going to get rid of that just because I'm going to use the space of 7,250 VA. You can do the math here. 7,500 times 0.8, and that should be 6,000. Well, I forgot my clothes dryer. Almost forgot the clothes dryer. No changes made to the clothes dryer. Again, we only have one, so 100% value. We do make a small change to the range. It becomes 6,000 VA after running it through the 80%. And then our heating pump comes in. And now you don't have to do this part anymore. We already did all that and got to the 9,000, so make sure we got that. All right, don't run all these numbers together again. And so now we just add all of this up. All right, everything gets added up. Does anybody have a total? Not yet, me neither.
I have a question. The garage door and the spa, what category are they considered under?
Those would be considered, let me see where we're putting those. Let me double check here. There would be other equipment. They would fall under other equipment. Article 22014.
38,640.
Say that one more time.
38,640.
38,640. Cool. So let me go over back to that article. So if it's not one of these other things, right? If it's not falling under one of these other things, then it falls under other loads, all occupancies. And then it goes specific appliances, not small appliances, right? Not just appliances. Now it's specific appliances that are not covered in the areas that are below this, B through K. So garage door opener does not fix multi-outlet assemblies. All right, we have all of our receptacle outlets, the office, other outlets. So that's where it falls under.
So it doesn't fall, it's not other equipment, it's specific,
It's under the other equipment, and there is where we find specific equipment or specific appliances. It would be Article 22014A, specific appliances or loads. And we can read it here: an outlet for a specific appliances or other load not covered in the below. And here you just, like it says, calculate based on the amp rating of the appliance or load to be served. Now, because we're trying to come up with a total VA, then we would have to take the amp rating of the appliance, know the voltage that we're connecting it to, and then come up with a VA. But instead here we just gave the VA. As I said, garage door opener, I would do the amperage times 120. For the spa, very likely, just given that big wattage there, this is a 240 volt jacuzzi.
Would the heat pump fall under non-coincident?
Heat pump is non-coincidental load, yes. And there could have been air conditioning here, or cooling system rather, if that was bigger than the heat pump. Now let's go one step further here and divide it. Let's do Ohm's law and divide it by 240 volts.
Mr. Perez, I have a question. For this
Yeah.
fog, we multiply by 1.25.
For
For this fog, why is it 7250?
You add the 750.
oh yeah, plus the 750. Yeah, plus the 7. No, I did not make a 125 increase on that. All right, so if you divide this out by 240, you should get 161 amps. However, we'll fall back and do a little bit more of this tomorrow, just looking at the time, and I want to do the other assignment as well. At 161, we are not done. To find the overcurrent protection device for this, we do have to bump it up by 1.25.
What do you have to put up by 1.25?
I'm going to double check on that, but I believe our feeder has to be bumped up by 125% because of the continuous load application. I'm almost 100% sure on that. Maybe I'm wrong on that. I'm going to double check that one. So let's do that one tomorrow. Let me just double check that. So right now, let's just land at 161, which would put this, technically, would put this at 175 amp breaker. But let me double check that. I thought it was, but I'm looking at the paperwork here and it doesn't seem to be part of it. So I'm gonna go with not part of it, although I thought it had to, but maybe because it already considers a lot of the values and demand factors already, then that bump is not made to the feeders. However, if we go back to our Article 215 feeders, right, it does say that continuous and non-continuous loads applied, and we do have to bump up by 125%. But now it's a little bit different because, yeah, it might be that we don't have to do anything and we just go straight to finding the overcurrent protection device. So let me just double check that, but it might just be that. No 125 applied. All right. Now there's going to be more to this. We'll get into more of this. We're going to get into sizing the wire, and we're going to apply the equipment grounding conductor. We can do a lot more to this as well. All right, give you guys a chance to ask. So you guys have a bunch of questions, so good. Let's field them all before. All right, now let's pull up this question. So, all right, 11:11. So the first question is going to be a lot, and then we'll go from there. And this one goes into the conductors as well. So, all right. All right, so let me head over here. All right, if there's no further questions here, I'm going to take a page because we'll work it out here. And I'm going to give everybody an opportunity now to work this out. All right, work this out on your own. I'm gonna be narrating. I'm gonna leave this here. I'm gonna narrate to help you come up with the correct information. I do want to change this question here. Sorry about that. I do not like the 10,000. Let's go with a. There we go. Let me see if I see anything here that I. No, I think we're good.
Does that change the answers?
Yes, that's gonna change the answer, so no worries as to where we landed here. Alright, so, sorry about that, let's go back over to one. It is gonna change the answer as far as that, and I'll apply the right answer once we get through with this. So not the correct number as to what's shown there.
And that's gonna update on our.
Yes, it's gonna update on that. Have you already turned it in?
No,
Oh,
just,
okay. All right, hang tight. Yeah. Don't turn it in yet. Let me make that change. Okay. So, like I said, I'll just narrate real quick through it as we read the question. What is the total VA for the following general lighting square footage? 2 small appliance branch circuits. Keep that in mind. 1 laundry circuit. Fastened in-place appliances. Oh, that was the other thing about the other appliances, like the dishwasher and the garbage disposal and things like that. Fastened in place, meaning these are not movable ones like the toaster and the whatever, air fryer, blender, etc. Again, just to give you a better breakdown of small appliance versus appliance. Fixed in place, meaning non-movable. All right, so we have dishwasher, water heater, waste disposal, garbage disposal, range hood. So we got 4 of those. Keep in mind the VAs for each. We have other equipment. This guy, whoever wrote these out, liked the spa. I think they wanted a spa in their house. Because you get spa a lot. And I like the word spa instead of jacuzzi. We got a clothes dryer. And we have an oven, and we have an air conditioning system. All right, take your time, no rush. Let's come up with the right answer here. All right, now I'm gonna run this calculation too. And I'm just working it out on the whiteboard, so once I wrap up that, and I'll have available answers if anyone has follow-up questions.
can you remind me again why range and range hood are separate, like, categories?
Yes, the range is the oven stovetop combo. The range hood is the little fan that's on top that pulls the air out. Those are separate pieces of equipment.
I was more asking, like, why are they separate?
Oh, they're just 2 separate things. Like physically, they're just not together.
Okay,
Yeah, so like for example, the other house that I had pre this one didn't even have a range hood. Had the oven, but didn't have a range hood. So they're not ever sold as, maybe that, I don't think I've ever seen an oven with the range hood combo. And then the range hood gets its own circuit. So if in the house, for example, you would have the oven sitting here, right? And then behind the oven would be that 50 amp outlet that I mentioned. And then above it would be the range hood with the little fan that's pulling the system out. And this would get its own circuit of 20 amps for that. And that would serve this. So they're just 2 completely different loads.
okay, thank you.
You're welcome. Now the only thing that I've actually seen combo is microwave that comes with a little fan, but you know, too many details there. And there you would just treat it by the wattage of whatever we were just told we're working with. would be considered a fastened in place appliance at that point. All right, so we have.
Yeah.
Now, the only thing you'll notice also, this one does not have an EV station. We could also throw an EV into this. Extras can show up as well, different things.
Mr. Perez,
Yes,
the range hood and the range are separate.
yes.
So do we want to count the range as part of the appliances or combine it with the range?
No, the range goes into the range article, table 22055.
Okay, so we'd add them together and then it's 75% of that, right?
No. This range hood is, whoops, sorry about that. That range hood is separate from the range.
Okay,
Yeah, range hood is separate from the range.
And then I put another. And then after this part, that's when you add these.
All right, I'll be pulling up the whiteboard here in a second. I'm just working out all of this just like you guys are. All right. All right, who thinks they got the answer? I think I have it, but I'm also making sure I didn't miss anything. Oh yeah, I was like, why is this answer so much bigger? It's because I went from 10,000 to 3,500 on the range. Yeah, I took out 8,000 from it. That makes sense.
Is the, Solon's rating 37,250?
37,250. All right, now I got a way different number, but we'll put it here: 37,250. See what?
8,475.
And I might have done some wrong math along the way. Totally possible for me.
For this, we could do 3,500.
Let me double check my math as we're going along.
Did you do two?
Yeah. 3,000. I even have to look for the frequency. The split. Yeah, because of the,
Oh wait, I did make a mistake along the way. Let me now correct it.
we have to split it. There's some. I think you're right. You're close. You're close to it.
Remember you changed it, you changed it so the answers are different. They would say 39,525, but because you changed it from 3.5 kVA or from 10,000 to 3.5 kVA, it changes it. And with the 3.5, that's multiplied by 0.8. You still got 39,450. And it's- Did you, 4,500, you took out the 3,000 and then you the rest of it to 35%? 35% of the 1,500, which is the 525?
Oh, yeah, that's, how did that come to 475?
Because I think that's 3,000,
Because this one's 28.
to
so that doesn't
3,000,
equal
1,500, 800.
I think that added up. 'Cause
I think
there's-
right here, you got the 4,500.
But there's no way I
3,000.
can get 475. There's all of this.
You got the full 3,000,
Oh,
you
not
gotta do the
this.
3,000 and the 35% of the rest.
All right, how we looking? Has anyone got a different answer from that one?
I did.
What do you got?
So I split it at 30,000, 525,
Have those two.
then you got 3,000, then 1,500, and then 800. Oh, 800 plus 28 plus 800, and then 500, right? That right there, and then you gotta multiply that by 0.75.
Just two 800?
Correct.
Yeah, 800, 800, 2,800, and 500. You add all those together, but you gotta multiply that by 0.75 because it's 4 or more over 500.
Correct.
Okay, that's where I messed up. So what was it again?
It was the total for those four.
You multiply by 75%.
Yeah, because they're over 500 VA.
For four?
For four or more.
For four or more, it's
Yeah.
over 500.
Yeah, for four or more over 500 VA, we multiply by 1.
All right, here's the number I got.
Oh, I see.
We're gonna walk it out again, little details, make sure we got everything, but we'll walk it out.
3,500. State series.
So this is a total from those.
750.
That's a total.
That's
That's
what
a total. I brought it up here, and then total down there. Did anybody else get the 38,240?
You put AL, what does the AL stand for?
Those were the all other loads.
Oh, okay.
Yeah, the fixed in place. So that was the dishwasher plus water heater plus garbage disposal, waste disposal, and range hood multiplied by the 75%.
For the small appliances, how do you get that number again?
Two of them at 1,500 each.
Okay, so small appliances is 1,500.
Yes, 1,500 mandatory for each. And laundry circuit is one of them and also 1,500.
Where'd you get the? You said OE is which one?
That is the other equipment, such as garage door 750, spa 9,500.
So the range is 28.
Yeah, the ranges are with 2,800 because it's the 3,500 derated by 80 or demand factor of 80. Dryer 100%, air conditioner 100%.
I thought the dryer you had to multiply by 0.8.
No, that's only the oven. The dryer, if we have 4 or more dryers, then there is a demand factor, but the dryer has no demand factor for 1 through 4 dryers.
Okay, got it.
100%. Wait, let me reframe this. That worked out good.
What was the very, what's at the very top?
It's 3,675.
Mr. Perez, did you add 8,025 plus the 3,675?
8,025.
VA after the laundry?
Oh, yes, plus the all those fixed in place appliances, and I came up with that number.
If I type that,
Is that not the right answer?
It's
It
easier.
might not be.
into the calculator, it's 11,700.
0.35
Okay.
equals
So there's where I made a mistake.
Put the G out, you just.
You were like so close, so.
Oh.
I don't know how you got 10 off.
I think I did the math in my brain. Wow, I was 10 off, so that's gonna be 50.
Yeah, 0.35.
Woo, okay,
This is
After
old fancy.
you-
Where is it from?
that should be 50. That means that coming down and everything else, let me correct these. I should have used my calculator instead of brain math. Wait, why is this less?
Still getting 37,250.
Yeah, I got that too.
You got 37,250?
Yeah.
What'd you get? Andrew? I'm still getting 37,250.
Yeah. Let me do this math here. Since I had that number off. And now, let's get rid of that total. And let's take everybody plus 6,000. Let me just double check on my end. 2,800 plus 6,500 equals, yeah, 37,250.
Yeah, we stressing over here.
Woo, me too. And so now imagine a journeyman exam. You guys did well. All right, let me put that one. I'm going to put that one as answer B, 37,000. All right, so now we all know what the answer is, 37,250.
So do we just click answer B on there, even though it's not that?
And now it is.
Okay.
Yeah, let me refresh. Don't put any answers in yet, because we're going to change the coming ones also. Let's just get our answers for now, and then you can go back and fill in the paperwork. So for question 1, that. So let's go to the next page over and take this into question 2, which is 37,250 divided by 240 volts equals an amperage. All right, we should have 155.20. We drop, keep the amperage at 155. So Article 240.6 would tell us this breaker has to be 175 amps for that breaker. Okay, so when it comes to total amperage, 155 is the total amps.
So we got well, I think it was 200.
Yeah, no, wait, so question two is that, let's go back one. This is question one. I'll put it here, I guess. Yeah, one. Question two, 155 amps. All right, that's for question two. Question three is now going to ask us what is the size of the main breaker. And here I don't have to change it because it stays the same. So Article 240.6, that's what I have here written, will give us this question three. Now, if you get an opportunity to memorize these, 15 amp breaker to 200 amp breaker is not that difficult. Other than the 25, 35, and 45, everything else goes 50, 60, 70, 80, 90, 100. Then it's 110, 125, 150, 175, 200. Not so difficult. I mean, I'm just rattling them off now like. So here's the table that I'm going to show you real quick. We're not going to do this right now, but we're going to answer this together so that you can have the answers to this assignment. We're going to put the correct code section so that you'll know where it's coming from.
Question really quick.
Yes.
Situation, are we not dividing by 240?
Never for a residential. We're always 100% of the time divided by 240.
Okay, cool.
Yeah, unless you happen to be building a place, which I think I mentioned to you guys, I once did a cabin. That's 120, and that's crazy, and I've never seen it other than that one place. It's always 240. So I'll write over here, Article 310.12a. All right, if anybody wants to go to this, it is on page 183. I don't have the page for 240.6. Although you guys should be putting tabs on 240.6, 310.16. These are all big tabbed out sections. You're going to go to this a lot. But if you go over to 310.16, it tells us the conductor size that we are going to use for single family dwelling services and their feeders. Unless otherwise mentioned, of course, we go with copper. And then we go, all right, if my main service is 175, then I am going to use a 1-on. You don't go, all right, just to point out what you don't do. You don't come over to this table. You don't come over to 310.16 and go, all right, 175, let me work my way down, and you'll see it's a 2-on. Now, could you buy a 2-on? Yes. You can put a 3-on if you want. But we don't use this table, 310.16, we use this table, 310.12a. All right, which this helps, and we're again, because we're going to be going into Article 310, we'll get back to this so we can answer this question from the assignment. It'll be a 1-on. All right, our 1-on, 175 is a 1-on. So I'll put it over here, 1-on. And this is question 4, 1-on. Just want to double check, make sure that's the correct answer on the thing. Yes, it's also the correct answer on it. It didn't change because question 3 and question 4 are both 175, and we fall with the 1-on as well. Now the last question on it. Alright, let's come back over here. So far so good. Let me just run through the whole thing. Make sure we got the 37250. There is our 37250. Question 1 is B. Question 2, 155 amps, right? Question 2, 155. That's A. Question 3, 175 amp main breaker, overcurrent protection device. Breaker or fuse, but we're just saying breaker. Question 4, a 1/0 is the conductor that we're going to use for that main breaker, not the 2/0. Can you 2/0? Yes. Can you 1? No. Can you 10? Obviously, no way. So the last question is saying, what size should the equipment grounding conductor be? All right, and this is going to take us to a completely different article and table. You guys will do Article 250 with Mr. Williams next module. Let me restructure this a little bit. I'm just going to put over here, I'm going to simplify what I have written here. 155 amps. Question 3 is 175 amps. In parentheses, I'll put Article 240.6. Question 4, bringing it over here, is the 1/0, and this came from 31012A. And then last but certainly not least is our number 5, our equipment grounding conductor, and this is going to come from Article 250. It's a table actually, not an article. It is an article, but this is a table. And let me, because there's a specific to the table. The article is 250.122, but if I'm not mistaken, the table is 250.122C1. C1 or maybe just C. But I'll find the table in a second. And it is just table 250.122. It's on page 158 if you guys want to go there. And just like the one that I just showed you, 31012, that says if you have this size main breaker, you're going to use this size feeder conductors or hot conductors. This table, same. Again, we always assume copper unless otherwise mentioned. This table is for minimum size of the equipment grounding conductor. And it gives us the same thing. If you use the overcurrent protection device sized, but now we run into a little problem here. We don't have our 175.
Which is
The next one up, next page.
Exactly. Our next one higher becomes our 200, and so our minimum size for the equipment grounding conductor is number, I can't highlight it, but number 6. All right, if we go back over here and we look at the answer, there is our 6 AWG. All right, that code section right there. And again, Mr. Williams, next module will run through Article 250, very big article. There's a table for sizing the grounded, the grounded conductor, the neutral. So we'll put here, number 6 is our equipment grounding conductor. And now that is, it's 11:40. I like when we land the plane right on time. I'm going to pause this recording. We'll have the